Today I'm going to be showing you 3 strategies to master 5.NBT.B7, and this is the Common Core State Standard that asks for students to be able to add, subtract, multiply, and divide decimals using concrete models and drawings, and then strategies based on place value. So today in my lesson I'm going to focus on the multiplication part of this standard of decimals. So when teaching this strategy, it's important that you have already taught some other strategies during 5th grade. So I'm starting out with a representational model of an area model. But before this lesson, it's really important that you would have taught students how to use concrete manipulatives to build an area model like this one. It's also important that they understand how to represent the manipulatives that they're showing based on their value. For example, this large square here has a value of 1 because it has an area of 1 with the length 1 times 1. They would also need to know that these rods that they're representing here with bars have a value of 1/10 because of their length of 1 times 1/10, and that the units in this corner here have a value of 1/100th because they have the length of 1/10 times 1/10. So before you can teach this strategy, it's important that you teach them the concrete strategy of building the area models. So this would be a later lesson in my sequence of teaching this standard. In this lesson, I started out by showing them a pre-constructed area model and asking them what was the multiplication equation that this student who drew this model was trying to represent. So I would ask students to look at this model. I might have them use manipulatives to build it to help them figure it out, but eventually what I want them to see is that this student was trying to represent the equation 1 2/10 times 1 4/10 to get a product of 1 68/100. So now I'm going to show you some strategies to help students move from the representational to the abstract. The first strategy I'm going to show you is estimation. So using those same two factors, 1 2/10 times 1 4/10, I'm going to show you how students could use rounding and estimation to help them determine the answer. So in previous grades, students have learned about place value of decimals, and they've also learned how to round whole numbers, and so they should be able to access this information with only a small review of rounding. So for this one, I'm going to use an estimation here, and I'm going to determine what is this first factor, 1 2/10, close to. Well, I know from my background knowledge in 3rd and 4th grade that when I round numbers, if the digit is less than 5, I'm going to round that down. So for this 1 2/10, this number is going to be close to 1 whole. Similarly, for 1 4/10, I could round this to 1 5/10 because usually 1/2 is a friendly number, but for this strategy, I want both of my factors in my estimation to be whole numbers without decimals. So again, I'm going to round this because 4 is less than 5. I'm going to round this to 1. That means the product of my estimated numbers is going to equal 1 because 1 times 1 is 1. Doing this estimation beforehand gives me an idea of what my answer for my original two factors should be close to. My answer should be close to 1. When I do this strategy, I add in a discussion now about whether my actual answer to my original factors will be larger or smaller than my estimated answer. So this incorporates some number sense in, because students should realize that because both of our factors are larger than our estimations, our product should also be larger than our estimation. So for this one, 1 2/10 times 1 4/10 should be close to, but slightly larger than 1. So now I'm going to get into actually solving my problem. In order to solve, because I have this estimation, I can pretend like my decimals aren't a part of this problem. So when I rewrite my equation, I'm going to rewrite it as 12 times 14. In previous grades and earlier in 5th grade, students have used the standard algorithm to multiply 2-digit by 2-digit numbers, so this should be an easy problem for them to solve. 4 times 2 we know equals 8. 4 times 1 would be 4. Using our place value marker, we'll mark that spot. 1 times 2 would give us 2, and 1 times 1 would give us 1. So now I can add them together. And I have 8, 6, and 1. Now this is where my estimation comes into play, because 168 is not the product. A common mistake that I'll see students do is they will simply write 168 as their answer and not think back about whether or not that's reasonable. The reason that we have them do this estimation beforehand is for them to decide what the placement of their decimal should be. I want my product that I came up with to be close to 1. If I place my decimal here after the ones place, my answer would be 168. That is not reasonable because it is not close to 1. Similarly, if I place my decimal between 6 and 8, between the tens and the ones place, my answer would be closer to, but still not near 1. 16 and 8/10 is still not reasonable. If I move it here, 1 and 68/100 is close to, and as we discussed before, slightly larger than 1. So that seems like it's going to be my best answer. Just in case, I'll check here. If I put my decimal here in front of the 1, my answer would be 168 thousandths, and that I know isn't reasonable because it is much smaller than 1. So that means my decimal point should go between the 1 and the 6, making my answer 1 and 68/100, which of course is what we got previously with the strategy of drawing an area model. The next strategy I want to show you is how we could use the associative property. Now this comes back to students' previous knowledge about place value, and in previous grades students will have used a place value chart in order to mark where decimals belong. So for this one, I'm again going to call on students' previous knowledge of using the standard algorithm to multiply 2-digit numbers without decimals. But in order to do that, I need to do some work first. So the first thing I want to do when I'm using this strategy is I want both of my numbers to not have decimals. So if I go down to my place value chart, I've written in 1 and 2/10. So to make this so that all of my digits are on the left side of the decimal point, I'm going to need to use my knowledge of powers of 10. So before teaching this strategy in 5th grade, it's important to make sure that you've really had students master their powers of 10, and that multiplying times 10 will move their digits to the left, and multiplying times 1/10 will move their digits to the right. In order to make this number all of my digits to the left, I'm going to need to multiply this times 10. So I'm going to show that on my place value chart. And now my number will be 2, 1, my number will be 12. Up here, when I rewrite this, I can't just magically make that number into 12. It still has to have the same value as my original factor. To make these numbers have the same value, I would need to multiply 12 times 1/10. So when I rewrite this, I'm going to rewrite this as 12 times 1/10. And I can write that as a fraction to reinforce the relationship between fractions and decimals, or I could choose to write it as a decimal. I'm going to choose to leave it as a fraction, and I'm going to put that in parentheses. My second factor is 1 and 4/10. I've written it in my place value chart here. Similarly, I need to make this all of my digits need to be on the left side of my decimal point. So I'm going to multiply this times 10. Once again, that makes my new factor 14. And again, I can't just wave a magic wand and make that into 14. It has to have the same value as my original factor. So once again, I'm going to need to show that I multiplied it by 1/10. Now this is where the associative property comes in. The associative property tells me that I can rearrange these numbers in any way that I choose as long as they all are multiplied together. So I'm going to choose to do what I'm familiar with, which is multiplying whole numbers by whole numbers, and I'm going to move those two factors together. So 12 times 14 I'm going to put in my first set of parentheses, and then I'm going to put my 1/10 in my second set of parentheses. 12 times 14, I would use my algorithm off to the side to determine that that equals 8 times 4, 2, 1, 168 times 1/10 times 1/10. And now I can multiply these 1/10ths together, and I can determine that that would really equal 1/100. So when I go down here into my place value chart, I'm going to write 168 just as it is, and because I'm familiar with powers of 10, it's easy for me to multiply 168 times 100th because I'm familiar with doing that from powers of 10. So I'm going to write 168 here, but then I'm going to use what I know about powers of 10 and I'm going to turn that into the appropriate decimal. So if I multiply this times 1/10, that would move my digit here. And if I multiply it times 100th, so times 10 times 10, times 1/10 times 1/10, that's going to give me my new number. So my new value, my 8, would be in the hundredths place. My 6 would move to the tenths place, and my 1 would move to the ones place. So now my answer, once again, would be 1 and 68 hundredths.